Hello everyone, hope you're doing well. So I sat down to record the Past the Developers for Aviation for March of 2023, and it turns out there are some ridiculously big articles and ridiculously dense ones as well. So instead today you get the McDonnell Douglas AV-8B Harrier 2 as an individual video. I'll cover the other stuff in the coming week. As always, hopefully you had a good weekend and enjoy the video. The first one is for America, and it is the McDonnell Douglas AV-8B Harrier 2. The story starts with the RAF and USMC, who were seeking to anticipate a requirement for a Harrier follow-on even as the aircraft was entering service. Hawker Siddeley and McDonnell Douglas joined forces to consider a new airframe, whilst Rolls-Royce paired up with Pratt & Whitney in engine development. Using as their basis earlier P1184 and 1185 series of schemes, the partners evolved the prematurely designated AV-16 and its Pegasus Mark 15 powerplant. Originally and provisionally known as AV-8C, the AV-8B was then reserved for the trainer, which became the TAV-8A, and then as the XV-16, the aircraft began as a Harrier fuselage with supercritical section wings. The US Navy, also in the market for a V or STOL combat aircraft, expressed no interest and used its superior position to order the Rockwell XFV-12A in 1972, but the project, of little use to the USMC, came to naught. The transatlantic partnership persevered with more advanced versions of the AV-16, which almost reinvented the P1154 but generated little enthusiasm. Finally, in March of 1975, Britain's government withdrew from this Super Harrier project, claiming that there was insufficient common ground to make continued partnership viable. A little over 6 years later, Britain bought back into the US program as a subcontractor, rather than the full-time partner it could have been, and went to order 110 of what was then called the AV-8B Harrier 2. In America, meanwhile, McDonnell Douglas had kept the Harrier alive by creditable exercise in refinement, which improved the aircraft whilst keeping costs to a minimum. With energetic support of the USMC, the St. Louis designers shunned uprated engines as a quick but expensive way of bettering the Harrier, and instead devoted their attention to doubling the AV-8A's payload and range capability through structural and aerodynamic means. A new, larger carbon fiber supercritical wing, together with widespread use of same materials in the forward fuselage and other areas, is combined with lift improvement devices to boost performance, while a raised cockpit with new nav/attack avionics enhances combat potential. With the same engine power, the AV-8B carries 70% more external ordnance and 50% more internal fuel, part of which can be traded off for 400% more external fuel tankage. Furthermore, it needs 60% fewer maintenance man-hours, 60% less ground support equipment, and can deliver its expanded warload with 200% improved accuracy. The new wing was first flown on the 9th of November 1978, attached to the 11th AV-8A, which thereby became the first two YAV-8Bs. It had 14.5% more area and 20% more span, although sweep is reduced by 10%. That makes the aircraft a little slower than its predecessor, but the only field in which it is inferior. The wing area is 230 square foot, excludes the leading edge root extensions added as a result of parallel British studies of a larger winged Harrier. 3 weapon pylons are under each wing, the outriggers of which have been transferred from tips to give a shorter wheel track for improved taxiing and operations from narrow public roads, sitting 12 inches higher than before for better view of a target and opposing aircraft. The pilot enjoys HOTAS controls and a far roomier and ergonomically efficient cockpit. The bigger wing increases the lifting capacity, provides 2 extra weapon hardpoints, and accommodates more internal fuel. But its carbon fiber construction makes it 331 pounds lighter than if made of metal. Similarly, 150 pounds is saved by building the forward fuselage from the same material. By making air intakes a more efficient shape, the equivalent of a saving of a further £600 was obtained. For reasons of heat resistance, the rear fuselage, which is built by BAE in Britain, remains much as before. Maximum weapon loads of the individual positions are £1,000 on the centerline, £2,000 on each wing, inboard and center pylons, and £620 on the outboard. Aircraft built prior to 1990 had £21,450 available from a Pegasus 1121 power plant, giving a maximum weapon load of rolling takeoff of £9,200, or a combined weapon and fuel total of £17,000. Maximum takeoff weight is £31,000 compared with £25,000 for the first generation Harrier. As an interim measure, the first 16 AV-8Bs had 404 power plants and a double row of pressure relief doors around the air intakes. Recently built aircraft have at last had the whip cracked over their flying horse, which is now persuaded to develop £23,800 as the Pegasus 1161. Development of the latter started under the company designation XG-15 in 1983, a first bench test following on the 22nd of October 1986. Aircraft trials in an RAF Harrier began on the 10th of June 1989. The engine having the fan pressure ratio raised from 2.3 to 2.6, a new combustor, improved cooling with the use of a single crystal fan blades, and improved reliability and maintainability that double the overhaul interval to 1,000 flying hours. Unlike the AV-8A and the AV-8C, the AV-8B featured almost from the start the huge AN/ASB-19 V2 angle rate bombing system, proven in the A4M Skyhawk. It was optimized for dive attack profiles and was linked to the new AN/AYK-14 mission computer and the Su-128A hood. The first two FSD aircraft initially flew with solid noses and extended test instrumentation probes, but later aircraft had distinctive glass nose associates with ARBS. Inside the cockpits, the AV-8B was a very different aircraft to any of its predecessors. Whereas the original Harrier cockpit had been entirely analog, unkindly described by some as an ergonomic slum, the AV-8B used a cockpit based on the design of the FA-18 Hornet, which in the late 1980s was regarded as the benchmark modern fighter cockpit with its HOTAS controls and large MFDs. The Harrier II was made to fly in an effort to reduce the high attrition rate. Advances in technology allowed the use of a sophisticated 3-axis Sperry stability augmentation and altitude system, or the SAAHS, linked to a department resistance system, or DRS, minimizing pilot workload in the hover and during the transition to and from the hover. The SAAHS even allowed hands-off vertical landings to be made, demonstrated by Bill Lowe in February of 1983. A USMC report entitled Frosty Nozzle had addressed the EW and secure communication shortcomings of the original AV-8A, and as a result, the AV-8C had incorporated a KY28 T-Sec secure voice radio, an AN/ALE39 dispenser, and an ALR67RWR, and provisions for the ALQ126C DECM pod. These systems were used from the start by the AV-8B, which was also planned to use the double ASPJ jammer. Two programs for further enhancement of the Harrier II's capabilities have been implemented. First of these, the Night Attack AV-8B, was revealed by McDonnell Douglas in November of 1984. A prototype was converted from production aircraft 162966 and flew for the first time on the 26th of June 1987 with a GEC Sensors FLIR sensor mounted prominently above the nose. In conjunction with a wide-angle hood, a new head-down display, a digital moving map system, and pilot's night vision goggles, this allows the Harrier to operate on clear nights, immediately doubling its combat availability. In 1989, GEC Sensors received an initial £10 million contract for FLIRs for the new Harrier variant. MDD designed a neat installation for it above the nose, allowing ARBS to be retained. The huge ANSB-19V ARBS is a daylight-only device, and is therefore redundant during night operations. The new US night attack aircraft had a new expanded field of view, or HUD, the 20-degree azimuth by 16 from 14-degree azimuth, to allow one-to-one correlation of the FLIR picture overlaid on the HUD. The aircraft also featured a new multi-purpose color display and a CRT-based digital map display, which retrieved data from an optical compact disc in the Hamilton Standard ANASQ 194 data storage set. The pilot was provided with GEC Cat's Eyes Generation 3 NVGs, with a field of view of 40 degrees in azimuth by 30 degrees, giving better peripheral vision outside the 22-degree cone covered by the FLIR. The Cat's Eyes MVGs featured prisms below the image intensifiers. The night attack Harrier also took advantage of a new engine, the Pegasus 1161, known as in the US as the F402-RR-408. This engine was developed directly from Britain's XG-15 engine technology demonstration program, which had been jointly funded by the British MOD and Rolls-Royce on a 70-30 basis. The new engine had improved fan aerodynamics and single crystal turbine blades, among a host of improvements and modifications. The hot end inspection cycle was doubled to 1,000 hours, and life cycle cost was asserted to have been reduced by 40%. Engine thrust was dramatically improved, with Rolls-Royce claiming a short-lived wet rating of 105.85 kilonewton, and McDonnell's claiming 108.96 kilonewton. Very significantly, the AV-8B NA was fitted with 4 extra Tracor AN/ALE-39 chaff flare dispensers above the rear fuselage, giving the aircraft a total of 180 flares or chaff cartridges, compared to the 60 on the standard baseline AV-8B. Interestingly, the AV-8B NA featured 100% LERX as well. The vehicle itself obviously could carry many different things. The gun fitted to the AV-8B is a development of the GAU-12U equalizer 25mm developed by General Electric. The gun was first trialed on a Harrier in 1980 and entered service with the USMC in 1984. The pods have been fitted with strakes to improve their aerodynamic effect. When the cannons are not fitted, Harriers are flown with long ventral strakes, replacing each entire pod. The gun is part of a 2-pod system. Each pod is 3.34 meters long, 350 millimeters wide, and 470 millimeters deep. The starboard pod contains 300 rounds of ammunition on the linear linkless feed system, which is connected at the rear to the cannon breech system in the port pod. The rotary cannon is driven by a pneumatic system that uses engine bleed air. The motor spins at 9,000 RPM, but this is geared down for the cannon. The cannon can speed up to its maximum rate of 3,600 rounds per minute in 0.4 seconds. The GAU-12 can fire a range of high-explosive incendiary, armor-piercing, and armor-piercing discarding sabot rounds. It also has a bunch of different stuff, all of the different missiles, bombs, and also, of course, rockets that you would ever desire from this second-generation Harrier setup. That is the good old AV-8B Harrier 2 for America. As always, I hope you have a wonderful day, and I'll see you next time. I'd just like to thank Millie Draper, Juan the Panda, Nick R. Kupila, Carrion Crow, Gus Irenicus, Pyman, Merciless Reaper, Orange Tail, Teddy, Daniel Stanton, Moxie B. Young, Peter Grayling, Jerry Provolt, Bareen, Alan Hacker, Sem Arslan, Uncle Bean, Derek R., and Lafouche for supporting the channel.